I'm traveling the world to find cutting-edge technology that can protect our precious resource, water, and tackle CO2 emissions out on the open sea.
We're combining a very, very traditional industry with something techy and cool.
I've heard of another game-changing AI machine that could be the key to decarbonizing the high seas right here in Singapore.
A vessel is this massive factory in the middle of the ocean and is really, really expensive. But people don't actually know what's happening on their vessel.
Singapore is home to one of the world's busiest ports. Every day, over 1,000 ships and hundreds of thousands of containers move through here. It's part of a vast global shipping network made up of over 60,000 vessels that deliver 90% of the world's goods.
I'm here in the Singapore shopping district of Orchard, and looking around me, almost everything I see, whether it's the clothes, the bags, the shoes, or the electronics, most likely arrived here by ship.
Our modern consumer lifestyles depend almost entirely on the shipping industry, which has enabled affordable global trade by moving goods across the world in vast quantities. But shipping accounts for nearly 3% of greenhouse gas emissions, pumping out as much carbon each year as the entire aviation industry. If it were a country, shipping would be the 7th largest carbon emitter in the world. How can we keep relying on ships, knowing the environmental cost?
I'm here because I've been invited to board the ship, the Hogue Tokyo, because I hear that they have some groundbreaking new technology that has the potential to shake things up for the shipping industry, and I'm keen to find out more.
So this is a ro-ro vessel, which stands for roll on, roll off, which means you're bringing cars in and you're bringing cars out. So this is probably about 6,000 or 7,000 cars going in and out of this vessel.
Joining me on this vessel is Rupert Grimes, who spent 11 years in shipping and now works with the company who created the tech installed on board. He's taking me to meet the crew and show me how it all works.
This is Louise, this is Captain Lowell, who is the master of the Hogue Tokyo.
Thank you for having us on the ship.
Captain Lowell has spent over 40 years at sea, sailing around the world on trips that last anywhere from 2 days to several weeks.
Captain, normally when you're traveling, where are you stationed? Are you here behind the wheel? Are you pushing
I'm everywhere.
everywhere?
Checking the ECDs, checking the horizon, checking the radars, the engine.
It's the captain's job to get the ship and its cargo to its destination safely and on time. He keeps an eye on everything from engine performance to sea conditions and fuel use. Every day around noon, the ship's officers compile a noon report with this data and send it to shore by radio or satellite. This helps shore teams track the ship and plan refueling or route changes. But traditionally, the captain would receive limited manual input from shore to help adjust his course. So if there were sudden changes at sea, he would mostly rely on his experience to navigate tricky waters.
I imagine over the years, it's getting more and more critical to get updated weather conditions because of climate change, and we're seeing the weather changing. Have you observed it changing over your career as a captain?
Changing
It's
every
changing.
time, every minute.
This is where Pythia comes in, a new AI-driven platform recently installed on board. The captain explains it collects real-time data on things like weather, currents, and fuel use. Basically everything happening on and around the ship, then processes all that info and suggests the best route for the vessel to move forward, making it way easier for the crew to adapt to changing conditions. This approach takes ship captaining to a whole new level.
right now. It's very accurate now. We can track bad weather very quick.
The captain has introduced us to Second Officer Ralph Samortin, who is showing us how the platform helps plan their voyages.
This is our next voyage from Singapore going to Thailand, Lem Chabang.
So what Mr. Ralph is doing now is filling in all the details to be able to set the constraints for the voyage. The vessel knows precisely when to arrive, when to depart, and what route to take.
What kind of constraints do they have to input in order to optimize the voyage? Like what factors do you have to take into account?
So there's a couple of key elements. The timings, particularly on a vessel like this, which is very strict. They have to arrive to get to the berth at a certain specific time. And then there are other certain elements such as restrictions on weather. So can this vessel go through wave heights of 4 meters or 5 meters? Can the vessel go through winds of 30 kilometers, 35 kilometers? Where do we constrain it? Absolutely, as priority, we have to keep the vessel safe.
Once all the constraints are in, the AI analyzes them together with the information it has on things like sea conditions. It then charts the best route and, this is key, recommends the ideal speed for each leg of the journey, separated by a series of wayward points from A to B and B to C, helping the ship arrive safely and on time. The best part? All of this helps the ship save a significant amount of fuel, which leads to lower costs and fewer CO2 emissions. And that's the main goal of the Pythia platform. But wouldn't just slowing down be the most effective way to save fuel?
For example, when I'm driving and I reduce the speed of my car, I'm saving on kind of the fuel emissions that I'm using up. And I imagine it's the same for a ship.
Yes, generally speaking, the slower you go, the more you're going to save fuel. However, there are also times where, depending on the weather, actually going a bit faster to get to a more favorable current later on in the voyage might be more beneficial over the entire voyage. Because if you were to go slower, you might not meet that favorable current later on.
Turns out, there are lots of factors that dictate how fast or slow a ship should go.
For example, if you're going through a piracy area, you probably want to put the ship at full speed, because for obvious reasons you want to get through that area as quickly as possible.
If you think about it, all the factors the platform takes into consideration to decide the right speed are like the old school noon reports. Just a lot more of them.
So the noon report, if you imagine, there's 365 of those in a year. When you have the minute-by-minute sensor data, you have, I think it's something like 500,000 sets of data through the number of minutes in the year.
A lot of data.
Once Pythia has filtered through all that data and suggested route and speed adjustments, the orders are sent from the bridge to the engine room for execution. That's where we're heading next.
Actually, they said that the bridge is the brain of the vessel, engine is the heart of the vessel.
Oh, wow.
Chief Engineer Rupert Regidor, who's been in the industry for over 20 years, tells me that before Pythia, captains were often stressed about reaching their destination on time. The pressure to meet tight schedules is intense. Being even a few hours late could lead to major financial losses, due to factors like delayed cargo delivery, extra port fees, and operational costs.
Kasi mostly kasi nakasama ko ng mga kapitan, mga navigator, yung distansya kasi mula halimbawa Africa to Middle East.
Right.
Yan, paspas na siya ng paspas.
So, speed is usually the priority. Even if it means pushing engines harder and operating less efficiently. Because ironically, in the end, ships often end up arriving too early.
Tapos pagdating doon, saka pa magsuslow doon, which is dagdag sa makina namin. Takbo ng blower, takbo ng double generator.
By using Pythia, the crew can now plan the journey more effectively, avoiding the last-minute rush to adjust speeds.
So when you integrated Pythia, how does it help with reducing emissions for fuel efficiency?
So when it comes to sa speed optimization, bawas tayo ng fuel, tipid tayo sa sa CO2 emission. So, nakakatulong sa in terms for climate change.
That is a lot of containers. It goes as far as I can see.
What we have here is one of the largest container terminals in the world. Singapore is, I believe, number 3 in the world for container throughput.
While optimizing speed and reducing fuel consumption is a huge step forward, there's still a lot of work being done to figure out how shipping can evolve for the future.
There's a very big push to see what can be the fuel of the future, whether
Right.
this is ammonia, whether this is hydrogen, what specifically is going to help shipping become greener, which is still currently being, discussed. But we're also seeing really, extraordinary kinds of engineering taking place, even things like putting sails back on ships, which obviously echoes back to thousands of years ago.
So looking into it, a lot more innovation has to take place.
But decarbonizing the industry would mean new ships, new engines, and revamped ports. And all of this change is going to take time, isn't it? The challenges are huge, and without a complete overhaul of the shipping industry's infrastructure, progress feels almost out of reach. Maybe this AI technology is what we need to start making a difference now. I'm curious to meet the brains behind the tech. Fittingly, its creators are based in a country with a rich maritime legacy. Greece is one of the world's largest maritime nations, a title earned through centuries of seafaring dominance. Today, Greeks own about 20% of the world's ships, and Athens continues to thrive as a global shipping powerhouse. Just a short distance away from Athens lies the port of Piraeus, which has been in operation for over 2,500 years and remains one of the busiest ports in Europe.
So I'm here in Athens, Greece to meet the people at DeepSea and explore how they're using AI to reduce emissions in shipping vessels. But first, look at this view! Isn't it beautiful?
This is kind of really a picture of the inefficiency of shipping. The fact that if you go to any major port, you always have just all these ships that are just sitting there doing nothing.
One person's scenic vista is another's floating case study in wasted energy. The inefficiency of ships is exactly what 30-year-old DeepSea co-founder and CEO Konstantinos Kyriakopoulos is looking to tackle.
I love the shipping industry. I love ships, I love being on ships, looking at them, the engineering of them, how they work. I love just the sheer complexity and beauty of the problem.
I'm curious, how did the seed of the idea for DeepSea come about for you?
The two co-founders of DeepSea are me and Roberto Clustas. I've known Roberto basically forever because his parents were the best man and maid of honor at my parents' wedding.
Oh my goodness.
Which in Greece is kind of like a semi-relative.
Basically family.
Yeah, exactly. He comes from a more traditional shipping background, from a shipping family. I did information engineering at Cambridge and then did a PhD in AI. At the time, to learn AI, you needed a PhD. Like now people do it in high school, but at the time, this was still a very cutting edge thing.
In 2015, during a summer break in Greece, Konstantinos and Roberto reconnected to discuss their projects. At the time, Roberto was focused on analyzing ship performance to cut emissions. The industry had a target, 20% below 2008 levels by 2030. One simple fix: slow down. Less speed means less fuel. But as we now know, it's not that easy. Tight schedules, unpredictable weather, shifting currents and tides. And little of that data was available in real time. But then around 2015, everything started to change, marking the beginning of a dramatic transformation. around 2015, communication technology, and in turn, the shipping industry, were undergoing a revolution. Companies began launching small satellites into low Earth orbit, kicking off plans for global broadband networks to bring high-speed internet to even the most remote areas. With these satellites in place, ships could stay connected to shore 24/7, exchanging information multiple times a day.
So before, you had one noon report a day, right? And suddenly they were getting per-minute data. And they were trying to figure out what to do with it. And then they just...
This flood of data presented new opportunities. Konstantinos' co-founder, Roberto Custas, was already working in shipping at the time.
And so the problem he was working on at the time was being able to predict how much energy a ship needs to maintain a certain speed. And the problem they were having is that over the course of the vessel's life, marine life sticks to the hull. And so it changes the equation.
Konstantinos explains that this buildup, anything from barnacles to algae to seaweed, known as fouling, forces the ship to work harder because it increases resistance in the water. That means it needs more energy to keep up its speed.
And so this meant that you just couldn't get a high accuracy. The lowest error all the best minds had gotten on this was somewhere in the region of 15% at the time. And he had this hunch that with AI, it could be done better. And I just trained a neural network. I figured out a way of dealing with the fouling problem, and I got the error down to 5% from 15.
Wow.
Right? And this was a couple weeks of work as someone with no background in shipping. It was because two worlds of shipping and AI don't really talk.
Yeah.
Right? And Roberto and I were two people that were in the right place at the right time in terms of straddling these two worlds, right?
With this new model that took into consideration things like fouling, wind directions, currents, and ship positions, Roberto and Konstantinos could now offer shipping companies an AI-driven solution to decarbonize their fleets by optimizing routes, speeds, and arrival times. They founded DeepSea in 2017, and in just 7 years, the company has expanded from a team of 4 to over 100.
So over here we have the AI team, and basically they take the huge amount of data we collect from all sorts of ships. We have now almost 1,000 years of sailing per minute data from all the different ships we've collected, and they figure out how we can use that data to build models, and then how you can use these models to determine the optimal actions.
That's incredible.
So this is kind of like the brain power.
To show me how the tech behind all this brain power works, Konstantinos has introduced me to the company's chief business officer, his sister, Alkisti.
We're combining a very, very traditional industry with something very disruptive. So if you think about it, a vessel is a very, very expensive and massive factory in the middle of the ocean.
27-year-old Alkisti tells me that DeepSea taps into vast amounts of data to revolutionize how these floating factories operate.
So what kind of data are you analyzing, and how does it reflect on the platform?
It's very complicated because there are a lot of factors that affect it. So it's actually a 19-factor model. But it's quite tough for a human brain to understand how one thing affects the other thing.
Right.
So that's where AI comes in. It can disentangle the impact of one thing on the other. So what impact will the current have on my fuel? What impact will the winds have on my fuel? Which one is more impactful? So this is a very nice example. The tiny little lines are the currents, and then the big ones is the wind. And you have the wind coming in one direction, the current coming in a different direction. But you don't know where you should go faster and where you should go slower.
Right.
It really depends on how high the wind is and how intense the currents are. And then whether the currents will impact you or not depends, for example, on how dirty the bottom of the vessel is.
Back to fouling. It turns out a clean ship does best following the wind, while a fouled one benefits more from sticking to the currents because it's more affected by underwater drag. It's a great example of how something seemingly random that is unique to a vessel can completely change the best way to set its speed.
So we're able to draw a graph of how this affects the power specifically. And then just think that you have a lot of these graphs and a lot of different factors.
Yeah.
And you can figure out, based on all of those, which is the optimal way to save your fuel.
Even just looking at this one simple basic graph, and then you'd have all those different factors, I can't exactly fathom or think about how to optimize my vessel in a manual way. So the AI comes in and kind of helps function as like a data analyst interpreter. Most captains still navigate the seas relying only on experience and instinct, especially since the decisions also change with every ship.
With this technology, you can have a specific graph for a specific vessel which acts in a specific way.
It's kind of custom built for each ship.
Yeah, basically, yeah.
That's brilliant. Today, DeepSea have over 500 ships in their AI fleet. But getting ship owners on board isn't always easy.
What usually happens in the beginning, which is the most difficult part of the job, is to actually prove to the customer that the AI works. Because this is black box and something complicated that most people don't understand. So we get our AI engineers to actually get past data from the customer. And we basically show them, if they had used our products, how much CO2 and how much fuel they would have actually saved. And through these operational savings, you're able to save around 10% on CO2.
A 10% savings on fuel might seem small, but that translates to about $400,000 and 2,000 tons of CO2 saved per year. That's like taking 500 cars off the road annually. With around 60,000 cargo ships in the industry, just imagine the scale of the impact. And with AI, more vessels mean more efficiency. The system gets smarter with every new ship it connects to, improving predictions and optimizing fuel use across the industry.
So the more data you have, the better data is power.
So it's like a hive of different ships that are just kind of working together to feed each other information that optimizes.
Basically.
That's incredible. Alkisty and the team know this isn't the only solution to decarbonizing the shipping industry. But they point out that large-scale changes will take time.
Operational savings on what you're doing at the moment can happen now. And we're in a rush. We don't have time to lose.
And I imagine this is so easy to transition versus doing like a completely new overhaul of the shipping system. It makes sense to start with relatively easier wins, optimizing existing vessels to make an impact right away. And this isn't just a short-term fix.
With a lot of like the big changes that are going to happen much more are going to happen on the new builds and on the new vessels. What happens to the ones that are actually in the ocean at the moment and are going to be there maybe 20 more years? So it's quite a complicated issue.
No, it is, but this is such a practical pathway forward. It's honestly surprising how practical this solution really is. AI isn't some high-tech concept for the future. It's being put to work right now, solving real problems. By the end of the decade, DeepSea aims to be the first to provide fully autonomous navigation for large cargo ships using this AI technology. The system would factor in all sorts of constraints, like weather, market conditions, nautical charts, and even piracy zones, to make decisions in the cloud and handle the minute-to-minute decisions on board the vessel to move it from port to port. And if the captain allows it, it could take charge and execute those various decisions. This technology's potential to reshape the global shipping industry is massive. It feels like we're on the verge of a new era.